Day 279 of doing the LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 201, bitwise and of numbers range. The difficulty level is medium, but don't worry because we're going to keep the solution as simple and easy to understand. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description. Now let's see what the question says. Question says, given two integers left and right that represent the range left-right, return the bitwise and of all numbers in this range inclusive. All right, y'all. So that sounds simple enough, but let's go ahead and look at example one because I understand how it could seem a little confusing as what it is that they're asking. So let's look at the examples. Example one, we have the input left and the input right. The output is 4. So I'm sure y'all are wondering, how do we get this output of 4 from the input left of being 5 and right being 7 when we're trying to find the numbers and the bitwise numbers of in the range of 5 and 7. So let me show y'all how. So what we're going to do is we're going to use the bitwise AND operator. First thing to understand or remember when we're dealing with the AND operator is we need to remember that all ones, if ones are in row in the column, well, let me write it like this, right? So I can show you better, right? So let's write 5, or hold on, let's say 5 equals, this right here is the binary representation of each number. So 6 equals, and 7 equals 111, right? So these all right here are the binary representations of these numbers, right? Of 5, 6, and 7, which is the range that we're working with. So what we want to do is use the bitwise AND operator, and we want to find what these numbers come up to, right? If we all of these numbers between 5 and 7, what will the bitwise AND operator come up to, right? So let's come down here. Boom. So now with the bitwise AND operator, we know if all ones are in a column, then it will be 1. Otherwise, if it's not all ones, then it's going to be a 0. So there's two different ways we could do it. But it'll come out to the same result, right? We could just start with these first ones. So we could come over here, say 101. Oh, my bad, y'all. Come right here, say 110. Boom. So we use the bitwise AND operator of this, and that will give us, well, let me bring this down here so it doesn't confuse y'all. My bad, y'all. So let's come down here. So let's say we have 101 and we have 110, right? When we use the bitwise AND operator here, we'll see that we get 1. So come down. This will be a 0 because it's a 1 and 0. It's not all ones. Then this would be a 0 as well. Boom. Because it's not all ones. And this is all ones. So this would be a 1. Boom. So it'd be 100. Then we still have to do this row. So when we come to this row, it'd be 111. Then we come down here. It's not all ones. So this would be 0. This would be 0 as well. And this would be 1. So we still get 100, which is 4. So either way, or if we do it all in a row, right, we can see if it's all ones. If say we was, bring this down here, but say we didn't want to split it up like this, we could just go 101. So we know 101, that's not all ones, so that's going to be a 0. Then we have 011, we know that's not all ones, so that's going to be a 0 as well. Then we have 111, that's going to be a 1 because it's all ones, right? So if we're coming by columns, this is all ones, so we got 1. This is not all ones, so it's a 0. This is not all ones, so it's a 0, which gives us 100. Just so y'all know, 100 equals 4. So we come right here, so y'all know. So this is just two different ways of doing the math or using the bitwise AND operator. You can do it like this and just do all the numbers. It'll still give you 100. Or you can split it up and do it row by row, right? And do it like this. And that'll give you this 100 right here. Then you take this 100 and you do the same thing, you'll still get 100 again, and you'll still get 4, right? So those are just two different ways of getting the same output, which is 4, and that's how we got the output. We took all of the ranges, all of the numbers between 5 and 7, which is 5, 6, and 7, boom, and we used the bitwise and operator for these numbers, right? So we converted these numbers into binary code, which is this right here. So this 5, 6, 7, and we use the and operator for all of those numbers in the range, and we get 4, or we get 100, which is equal to 4, and that's how we got this output of 4. So example 2 would be 0, 0, we get 0. And this, I'm not even going to go through this example, but just we'll trust the example when it tells us that the output would be 0. So now that we understand the question, y'all, let's get into the fun part, the actual solution. Solution is not that difficult at all, y'all. And guess what, y'all? I'm going to give y'all two different solutions today just because these solutions are so simple and easy to understand. I'm going to make sure to give y'all two different solutions, and y'all can use whichever one you're more comfortable with. So the first thing we're going to do with this first solution, first thing we need to do is we need to create mutable copies of left and right, and then we're going to initialize a shift counter. So in order to do that, we're going to declare a variable, call that left, and we're going to set that equal to left. Then we're going to declare another variable called right. We're going to set that equal to right. We're going to declare another variable called shifts. Set that equal to 0. Boom. Now we need to start our while loop, which will reduce the left and right until they become the same, which will help us with our range, right? So we count down or count up in between our range, right? Count 5, 6, or 7, or count 7, 6, 5. However we want to count it, but for us, we're going to say while right is less than left, boom. What we are going to do is we are going to right shift both numbers by 1, which is the equivalent of dividing it by 2. So we're going to say right, then we're going to say greater than, equal sign 1. And what that is going to do is it's going to shift the number by 1, right? That's what this 1 does. It's going to shift it. It's going to shift it by 1. This right here is going to shift it, and this 1 is going to tell us by how many we want to shift it by, which in this case we're going to shift it by 1. So let me give y'all an example of what the shift looks like as well, so you could visualize it. So say we had a var num, and we set that equal to 8, right? And binary code, that's just, we put some commas, that's 1,000 in binary code, right? And then we say, we say num, then we do this shift sign right here, right? Boom, this shift sign, we say num, and we want to shift by 1, right? Then the output of that would be, if we shift num by 1, the new output would be, say we said print num after doing this, right? We would say it would look like this. The new binary would be 0, 100, which is equal to 4. Again, that's just a coincidence though. But as you can see, we shifted this to the right by 1, right? So boom, we shifted this 1 over to the right one, shifted these 2 zeros over to the right one. This 0 got left off, and we put a 0 over here. So it went from this to this. That's how the shift works, right? As you can imagine, we're just taking this right here, we're shifting it to the right, right? We're shifting this down to the right. We're shifting 1 to the right and the 0s to the right. The last 0 gets cut off, but we put a 0 right here to replace the 1, and this would be equal to 4, right? So then it equals 4. Boom. So let me just give y'all another example of that. Say num equals 32 or something, right? And which that would be 10,000 in binary. And say this time we wanted to shift it by 3. So who knows what it would look like if we shifted it by 3, right? Well, let me show you. If we shifted it by 3, then this would be, we would shift it to the right by 3. So we go, now it'd be 3 zeros in front of the 1. Then it'd still be 1, 0, 0. Boom. So as you can see, it's just shifted by 1, right? We're putting 3 zeros in front and we're moving it to the right 3. Boom. That's what the shift operator does. That's what it would look like. That's just an example for y'all. So, excuse me, y'all. This would be 100,000 though, not 10,000. So imagine we took this 100,000 and we shifted it by 3. Boom. It would look like this. These 3 would become zeros. The 1 would become right here, and then the output would be 4. So that's just an example of what the shift operator actually does, just so y'all can see. Boom. Now that we understand what that does, now you can visualize what this right shift is doing. Then we need to shift both numbers, actually. So now that we know what the shift actually does, come back up here. We need to shift left as well. Boom. And then we're going to come down here and we are going to say shifts plus equals 1. Boom. So this shift is going to keep track of how many shifts we actually used or actually did. Then we need to come down here and we need to left shift the result back to restore the original bit position. So this keeps track of the shifts. So we're going to come down here and we're going to say return right less than shift, which is going to shift the result back to the restored or to the original bit position, right? Because that's why we're taking count of how many shifts, so we know how many times we need to shift back to get back to the original position. So now let's run this, y'all. Let's run it, see how it runs. Ooh, we got an error. Shift. It should be shifts. Sorry, y'all. Let's run it again. Boom, and it's accepted, y'all. So I'm going to go ahead and give y'all this last bit of code, or this last solution. The solution this time, not that difficult. And guess what, y'all? We got a one-liner. That's right. The second solution we could do in one line of code, not that difficult. All we're going to do is open up the parentheses. We're going to say left, ... right. Then we're going to come out here. We're going to say .reduce. Open up the parentheses. We're going to say .max, comma, and. Excuse me, y'all. So this is going to use the reduce function to compute the bitwise AND operator of all the numbers in the range in between left and right, y'all. So the reduce function is going to iterate over all of the numbers from left to right and return the bitwise AND operator. That's what this is for. We use the dot max. We're just using this dot max, right? Because it represents the maximum possible integer value, which will ensure that the result will be computed correctly. So let's go ahead and run this. Make sure this runs like it's supposed to. And it's accepted, y'all. So let's go ahead and submit it. My bad, I didn't submit that first solution because, well, I'll submit it after so we can see what that time is looking like as well. Okay, so this one-line solution had a runtime of 3,058 milliseconds, beats 5.66% of users with Swift. Could be better, y'all. Could be much better. But let's look at this other solution that we did so we can see what that runtime is looking like. So, my bad. I wonder if I can Control Z this. Yeah, let me just Control Z this. Boom. So let's submit this code and see what the runtime looks like. Ooh, and this one is much better. Look at that, y'all. 0 milliseconds beats 100% of users with Swift, y'all. Not too bad at all. I hope y'all learned something today. Don't let anybody dismantle y'all dreams, y'all. Don't let anybody tell you what you can and can't do. We're in this for the long run. We're in it to win it. You know we're here every day doing another day, another LeetCode problem. I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. I'll see y'all then.